Now I would like to introduce Randy Zhang, who will be presenting how to converge IP and optical, a deployment example. Randy is a principal architect at Cisco Systems and is coming to us today from Virginia. Randy, it's a pleasure to have you with us today.
Is that on? Thank you, Mike. All right, good afternoon. Hope you're doing well with the lunch, and always a little bit tough after the lunch. So hopefully I'm not gonna make you fall asleep. So work with me, and let's get started. Today's topic is about converging IP and optical together. And we're gonna start with an introduction, what it is, what some of the benefits, why we're doing that. Then we're gonna get started. Next is how to start that journey with IP optical convergence. We're gonna spend most of our time on the practical example so that you get a feel what are some of the things you may run into, some of the things you may think about when you deploy IP optical convergence. Before we get started, let's have a quick review what we have been in terms of the evolution of the multi-layer IP optical network. Start with the network services. If you look back decades ago, most of the services were TDM based. Now IP services predominantly. If you look at topology, RAIN was a common architecture. Now more and more you see mesh-based architecture topologies. And traffic patterns. And if you look back, there were a lot of hub and spoke kind of traffics. And now more any-to-any. And network layers, purposely built network layers, very distinct network layers. Now we're trying to merge them or converge them. That is the topic of today. Let's compare and contrast between the traditional architecture and the converged architecture. Traditional architectures were built purposely, again, with different layers, with clear demarcations between layers. They were done for a reason. With the converged architecture, what we're really trying to do is trying to break these silos, break the boundaries between the layers so that we can increase the efficiency. Because of the silos of the layers, you're going to get complexity. You're going to get some of the resources overlapping between the layers. With the converged architecture, what we're really trying to get to is a much simplified architecture. And with the simplified architecture, we get simplified operations. With the traditional architecture, you're going to get limited service agility because of all the silos, all the layers, all the complexity. With the converged architecture, we're going to get faster time to value, faster service provisioning. Some of the better operational models can be implemented. Let's try to summarize what exactly, or define what exactly we're talking about in terms of the converged optical, IP and optical architecture. First, let's look at the optical transport network. With the converged architecture, we are looking at a more disaggregated optical transport with redesigned traffic patterns, much better mapping of topologies of all the layers. As a result, we're going to get much better wavelength utilization or bandwidth utilization or fiber utilization. Then, working. Then we're going to look at the second part of it, which is common packet transport. We're trying to converge, right? The theme here is trying to converge. By converging the common packet transport, you can build multiple services on top of that transport. For example, private line services. We talked about earlier that TDM services, private LAN services were predominantly the driving forces of the early network architectures. Now we're moving into IP-based services. Do we still need to maintain dedicated private LAN services? Can we converge them into a common packet-based transport infrastructure so that we reduce costs, simplify the operation? The fourth point is end-to-end automation. To bring all these services together, we need tooling. You've heard in the past couple of days a lot of the tooling discussion. How do we bring all this together with automation, with end-to-end service provisioning, assurance, all these areas part of the operations? Let's look deeper. What exactly are we converging? First, the layer convergence. By layer convergence, we are trying to converge the network layers by removing some of those components. Specifically, we're talking about the digital coherent optics. Once you bring them into the routers, there are a lot of benefits which we're going to address a little bit later. The service convergence is to converge the different type of services into a common architecture, like a packet transport, as we talked about, to remove or reduce dedicated infrastructure for private LAN services so that you increase efficiency. Topology convergence is that we're trying to move up and down the layers, the fiber layer, the optical layer, the IP layer, Ethernet layer, the overlay layer. We're trying to make them as congruent as possible. The benefit of that is you simplify your network operations. The management convergence is trying to bring all this service orchestration, provisioning, assurance into a unified view so that you don't have to touch all these different places to get the visibility of your network, right? That's number one. Of course, then the service assurance and how to troubleshoot, how to fix issues. Last but not least is operational convergence. How do we converge business processes? When you are in a converging architecture, some of the things that used to work may or may not be applicable today with the converged architecture because it is intended to break some of the silos, change some of the ways that you are used to work. With that, some of the processes, some of the tooling, some of even, let's say, the organizational structures and organizational culture may have to be enhanced, optimized, or even changed to deliver or realize the benefits of the converged architecture. Let's take a look at an example of very simple architectural example of layer convergence. On your left is the traditional architecture, multi-layer architecture with the routers, with the transponders connected through gray wavelengths. Gray by gray, they are not color, that's the contrast, to the DWDM system. If you look at the converged architecture, which is much simpler on the right, routers can be directly connected to the DWDM system through a color wavelength without transponders. So let's summarize the key benefits of the convergence. First, a simplified network architecture. With that, you get lower cost, higher sustainability. With the simplified network architecture, you get much more optimized network lifecycle management. Your operations, your tooling, your organizational structures can be simplified. As a result, you get much simpler, more efficient operations. With the new architecture, you get increased operational agility, faster time to value, because a lot of the extra processes may or may not be needed anymore. Some of the toolings may or may not be applicable anymore. And you can remove some of these extra burdens from your network so that you increase the operational agility, faster service to customers, better customer experience. Now let's look at how to get started with the convergence. To build a convergence story, one of the first few things you have to do is to align with the business initiative. We're doing architectural convergence not because we want to do it for the sake of technology, which we do as technical people, but you have to align with the business initiative so that you build the relevance to the business. Second part is to identify a key technology insertion points so that you can attach your convergence journey to the business initiative through these insertion points. We're going to talk to some of those a little bit. Then from there, you can build a set of use cases. These use cases, again, are aligned to your journey, aligned to your business initiative, right? So that they are relevant to the business that you are with. From there, you can construct a platform for continuous improvement. And let's face it, the journey of convergence is not like an easy one-day job, right? It's going to take some time. You're going to maybe doing it for months, even years. So you need to have a platform so that you can come back to continue to build up that platform and revise that platform to demonstrate the business results as you go through. Let's quickly look at some of the business initiatives. And you may have a lot more than this, but some of the common ones, I would say, capacity increase, speed and fee, they're always there. Nobody is going to dispute this. The cost reduction, right? Everybody wants to reduce cost. And if you can attach that, you show, yeah, I can reduce cost. That's going to be a wind behind your back. Network transformation. We're always doing some form of a network transformation, one way or another. There are plenty of transformation initiatives out there. Architecture simplification. Very relevant to this conversation, right? Simplify the architecture. Agile service delivery, we talked about a bit earlier. Now the new one, sustainability and circular economy. You see all the buzzwords on these things, right? It's very important these days for companies or operators to build that image of sustainability so that you demonstrate not only to the customers, to the society as a whole, you're on the path of a sustainability. If you can attach to one of these initiatives, you are much more likely to be successful. We talked about these types of convergences, right? Layer convergence, service convergence, topology convergence, management convergence, operational convergence. We talked through these 5 convergences earlier. Now let's try to find some use cases that will help us to link to those convergence stories that we're building. For example, we're going to spend a little bit more time later, integrate digital coherent optics into routers. Architectural redesign. We talked about the disaggregation in the transport world. That's been going on for a long time. And architectural redesign is to really simplify how the transport network is going to perform. Not necessarily the previous way of doing things, maybe a new way, a better way of doing things or delivering your services to your customers. Migrate OTN to private line emulation. This is a big topic. Some of you probably have still OTN services for a reason. Do I need to still deliver that OTN services today with a dedicated OTN infrastructure? Maybe yes, maybe not. This is a good time to reevaluate whether some of these OTN services can be migrated to a packet-based service infrastructure. End-to-end orchestration and automation. We heard quite a bit today from the automation survey, right? Everybody wants to do automation, I assume. Nobody's going to say, we're not going to do automation. We will, right? It's what is automation? How do you do it? What is the cost? What is the outcome? A lot of questions. Segment routing. How many of you are already running segment routing? Wow, only a few? 3? Okay, there's a lot of potential for synchronous routing. That's a valid use case for combining, simplify your MPLS infrastructure. Operational efficiency. That's also a buzzword. People are always trying to increase the operational efficiency. With a set of use cases, you can build a journey out of those use cases. This is just a hypothetical example, use case 1, 2, 3, 4. Each use case may have specific business initiatives, outcomes tied to it. For each use case, you may go through multiple phases, which we're going to go through that a little bit later on that practical example. Select, deploy, and operate. By select is we're trying to understand the use case, understand the architecture, the business problem you're trying to solve, right? You're always trying to align with the business initiative. You perform business modeling, maybe ROI modeling, TCO modeling, doing a lot of those things, making sure what you're going to do is aligned with the business. And once you have the architecture defined, you can create the use case, define the use case, even perform proof of concept testing. A number of other things going to take place. The second part is to, once you have the use case, you're going to deploy the use case, create the design, create the implementation plan, actually stand up that use case in your network. And the last part is to operate, right? The network is not going to operate by itself, even if we wanted to or wish to. And we have to be involved to operate that network. And some of the things that we need to take into consideration, how to integrate the technology, especially when it comes to convergence. Some of the things may or may not be applicable, right? How can we integrate the new technology into our day-to-day operations, which were designed for previous generations of technology in many cases? And how do you transform your operations? How do you transform your businesses? How do you transform your processes, organization? A lot of things, organizational structure, culture, a lot of things going into that. Now let's look at the practical example. Anytime when you start a journey, build a complex journey like a convergence, you need to, again, understand what you're trying to do, where you're going, right? That's typical what you do when you make a journey, and how to get there. In this simple example, we're going to look at the integration of digital coherent optics into routers. The target is that the transponders are out of the network. They are replaced by the DCOs inside the routers. Routers are connected directly, not through transponders, but through color wavelengths directly to DWDM. You remove a big chunk of that infrastructure out of your network. When we typically think about that chunk of infrastructure, we don't normally associate with additional costs that are with that infrastructure. The cost of the equipment, right? The upgrades, the power supplies, the batteries, ACs, and staffing, tooling, a lot of those things, processes that go with it, they are normally hidden. Once you remove that piece of infrastructure from your overall network, many things may be improved. Here's a quick example looking at the 4x100 gig with the routers connected to the transponders to the outside fiber plant. With this example specifically, what we're going to do is we will be able to eliminate a number of these components from the network. What you're going to get is much simplified architecture with routers directly connected to the DWDM transport through digital coherent optics. We talk about 3 phases of implementation: select, deploy, and operate. Let's quickly review some of the steps. First is 400 gig readiness assessment, 400 gig upgrade, transponder to optics migration, and then the operational update. There are several important things we want to accomplish with the 400 gig readiness assessment. We want to understand the 400 gig signals, what they are specific, what some of their unique attributes are. We need to have a strategy to insert the 400 gig DCO into our network. And the third step is we're going to summarize what is the gap, if there's a gap, what needs to be done for us to get to the next step. Quick review of the 400 gig digital coherent optics DCO signals. There are two standards bodies. You probably heard quite a bit. The OIF defined the 400 gig ZR signal, which is 16 QAM, about 60 gigabaud signal. It's designed for the metro applications. The OpenZR Plus is MSA. It defines the ZR Plus or ZRP optics. It is 16 QAM, 60, it's about 60 gigabaud. And what's different with the ZRP is that you can support multiple line rates, multiple client rates, 100, 200, 300 gig, in addition to the 400 gig. And it is optimized for the regional long-haul networks. As an operator, you need to understand what are some of the performance metrics this signal is going to bring, how to monitor them. Because optical signals are analog signals. First thing you have to monitor and understand is the powers, right? The transmit powers, receive powers, errors, signal to noise ratio, because again, it is an analog signal. You want the signal to noise ratio is very good, right? Measure in dB. Then you understand the bit error rate. With the DCO, there's the forward error correction capability so that you can correct during the forward transmission direction without retransmission. And the optics going to report to you the pre-FEC errors, the errors that are before the FEC and the post-FEC. If there are any errors post-FEC, you shouldn't see any post-FEC errors. If you do, there are problems, right? And two other metrics that use commonly to monitor, the Q factor, the quality factor, is directly related to the signal to noise ratio. So Q factor is a very simple representation of the optical SNR. Q margin is another way to monitor the signal strength before the FEC and after the FEC. These are just some of the optical parameters you may monitor to understand how good the signals are in your network once deployed. Now let's look at some of the insertion considerations. 400 gig signal is 75 gigahertz signal. That means you need to have a 75 gigahertz bandwidth for that signal to work. What it also means, if you have a 50 gigahertz DWDM transport, it is not going to work for the 400 gig signal because you don't have enough bandwidth, right? And the second part is you want to ensure there's interoperability. ZR, again, is already standardized by OIF, and ZR Plus is standardized by the MSA, OpenZR Plus MSA. ZR, typically, there's a good interoperability between the vendors. ZR Plus is not yet fully there. So if you're trying to interrupt at the ZR Plus level, you may need to do some extra work, proof of concept testing, and talking to the vendors of the optics. The other point I think you probably heard yesterday from some of the presentations that there's a newer generation of the ZR Plus optics, which transmits at much higher power, such as 0 dBm transmit power, which is more 10 dB more than the first generation of ZR plus signal, ZR plus optics. That gives you much easier interoperability with the LAN systems, which is designed for the 0 dBm optical signal. Just to keep that in mind. Yeah. Now let's look at the 400 gig DCO insertion options. There are multiple different options where you can insert into your network. Let's first look at the access network. The access network is typically characterized by like limited space, right? Limited space, limited power supply, and the cost. A big part of that is cost because it's spread out, it's far away, a lot of those locations. And the typical topology is ring or open ring, point-to-point, hub and spoke. A lot of these things you need to take into considerations if you're trying to insert into the access network. The next part is the point-to-point network. This is very common for the data center, metro space, and the signals can be either amplified or unamplified, depending on your distance. The ZR, for example, if it's amplified, you can run up to 120 kilometers. If it's unamplified, the distance is much, much shorter, depending on your requirements, how far your data centers are to each other. Then some of the networks, like regional or long-haul networks, they could be meshed. In the mesh network, it's a lot more complexity when you're trying to insert into that kind of network. The DWDM network could be colored or colorless. We talked about that earlier. It could be directional or directionless. We call the CDC network. There's a lot more complexity to figure out where to insert, how to insert, what kind of wavelengths, what kind of power structure, whether you need to have new amplifiers. A lot of things need to go into that conversation. When you're doing a convergence from a migration from transponders to digital coherent optics, it is very unlikely you're going to do it in one day. It's going to take time. It's going to take months, even years. And in the meantime, you're going to run a hybrid network that you have transponders still in your network. You have DCO going to be inserted into your network. You're going to have this hybrid network. How do you design or operate a hybrid network? So there are many options. We're just going to focus on two options. The mixed option is where you have the transponders and the DCO. They are in the same add-drop structure. For example, with the newer generation of ZR+, you can directly integrate into the transponder network without change because the power is already balanced. Or you may do the separate way of insertion. By separate, that means that you cannot directly integrate together into the same add-drop infrastructure. What you have to do is you have two separate add-drop infrastructure. One for the transponder networks, one for the DCOs. And before they are inserted into the what we call the WSS wavelength switch, you have to balance the power, make sure the powers are balanced. Here are some of the things that we want to document before we move forward so that we understand if there are gaps, if there are any things that we need to take actions. I'm not going to read through, but some of the key things, for example, power space, cabling, because you may redesign your central office or data center for those new insertion. The hardware and software, of course, optical topology, optical line system, hardware, software, and some of the other parameters that you may need to think about. Then move on to the next step, which is to upgrade. Now that we finished assessment, we understand, let's assume we understand we're ready. right? We can upgrade. Now let's perform the upgrade and define what is the upgrade plan. We need to create the scope. What is the scope? Do we upgrade software only? Do we upgrade hardware? Do we need to upgrade both hardware and software? And ask a number of questions. Remember, the assessment may be done well in advance, maybe long while back. So if that's the case, we need to ask, has there been an assessment done? Is our network still ready to go, right? Some of those questions, do I need to do a proof of concept testing just to validate? And create solution and upgrade procedures always very important as part of the deployment. Now moving on to step 3, which is migration. Finally, migration of transponders to the optics. Here are some of the things, there are a number of things that we can take into consideration. We're just going to summarize the 3 key pieces. One is you need to understand the transponders, discover them, where they are, what kind of transponders, all of the optical parameters that we talked about. What kind of wavelengths is using, right? What kind of power structures, what is the transmit and the receive power? Again, they're analog devices. Then we need to prepare the line system and to prepare the routers ready to go for the upgrade. Of course, we would love to have procedures written down. In a service provider environment, you definitely need to have a procedure to do the upgrade. Let's look at the 4th step, which is the operational updates. Now that you migrated your transponders to optics, what are some of the things that we need to do to make sure we can operate the network? We want to be able to absorb the new infrastructure, in this case, the digital coherent optics in routers. We want to be able to operate them, manage them, monitor them, support them, right? A lot of these things have to come, be documented and resolved if there are any gaps. I'm just going to highlight a few things here. First, clarify the organizational structure. Because in the traditional silo model, the transponders are owned by the optical team, right? Now that's been taken out from the optical team, moved into the routers. It's kind of similar like a transponder, but it's just pluggable optics. Who's going to own it? Is the routing team? Is the optical team? Is the joint team? There are consequences, there are implications, right? Then how do we align the management tooling to go to manage this new entity into the network? What are the processes? Maybe you have a lot of processes turning up certified transponders. Can you reuse some of those processes, or you have to create new processes because they are very different, right? Even though they perform similar function, but they are quite different now. They are hosted inside a router now. And for the purpose of the support, now that the optics inside the router, part of the routing platform, even though it's an optical piece, how do you support them? How do you hand off between the teams, the IP teams? Who's going to pick up the first call? Who's going to really resolve, arbitrate what the problem is? Who's going to get the escalation? How do you really resolve issues without impacting customers negatively? And we really want to have a graceful handoff if there's a handoff needed from one team to the next team. That means processes, that means tooling, that means training. The last part is training. And we need to create cross-trainings between the teams because now they have to work together, right? Maybe prior to that, maybe there are 2 different teams, there are 2 silos, two totally different organizational structures. Now they have to collaborate. So how do we train them to support this new entity? Perhaps one of the things, Optical team learn the IP technology, right? Not foreign concept. IP team learns the optical technology so that we understand each other and work together as one big team. There are different models. We're just going to look at 3 models of the asset ownership. Optical team owns it, or IP team owns it, or maybe a Converge team. If you happen to be one of the few organizations already have a Converge architecture. The optical team ownership is more akin to the traditional silo model because, again, optics is part of the optical network, just like a transponder, so it makes sense for the optical team to continue to own it. But then you need to figure out a few things because the transponder, they could totally own it, right, previously, but now the optics is part of the routers. It's on the different operating system. It's a different kind of CLI, different kind of tooling. Can optical teams actually absorb that? So that means some training, some process update, some new skill set, and mindset change. Those are the things have to take place. And then how to support it, right? How to support it when problems come up. Is optical team going to pick up that call? Or is the routing team going to pick up that call? Who's going to pick up the call? Who's going to support the escalation when issues cannot resolve? The second model is the IP team. This is more suited for organizations that already have IP-centric organizations, that you have a big IP team. Optical team is relatively small or already organized in a way that IP team owns a lot of the assets. It makes a lot of sense for IP team to own the asset because optics is just another, DCO optics is another kind of optics, right? IP teams already knows about optics. It's just different kind of optics, even though it has some more parameters, a lot more parameters, a lot more complexities underneath, many layers inside the optics. And the Converge team obviously is much more ideal because teams, you can work together, talk to each other, and really understand how to troubleshoot and turn up and provision all of these things in a single organizational structure. Again, the ownership model may evolve as you adopt the journey of the transformation or convergence. Here are a very simple example of operation model evolution. You start with the status quo with coordinated operations, then you move on into the accelerated operations. I draw a little person over there with slightly 2 different colors, just to illustrate this person is more converged, has both sides, understands both IP and optical, then eventually moving into the converged operations. So at the end of the journey, you want to really evaluate, again, going back to the discussion we talked about it, any transformation, any convergence type of journeys requires the buy-in from the management, requires buy-in from the business people. So you need to understand what you're really trying to achieve. Have you achieved those? Have you achieved those outcomes? You want to get back to the team, get back to the management, what you have done. You want to evaluate, right? And then is the optical team or IP team or Converge team, are they ready to support in production? Are there any gaps that we need to address? Any tooling gaps and organizational gaps, training needs, even moving people around or creating new job roles? That's probably another thing that you can think about. So we talked quite a bit, and I want to leave time for questions and feedbacks and comments. So I'm going to conclude with a couple of slides. So the key takeaway points: convergence of IP and optical brings enduring, real business benefits. The journey may take different forms, may take different steps, may take some time. Sometimes it may take a long time. And you want to be flexible, you can construct use case-based journey so that you can align those use cases with your business objectives so that you are relevant to the business you belong to. The final slide I'm going to leave you is the 3 steps of implementation. The purpose of this talk is deployment, trying to get down to the ground level how to make that solution work, right? The 3 steps I talked through: select, find the solution that fits your needs. Then deploy the solution, create the plans, create the upgrades, procedures, whatever you have to do that perform that exercise. Then finally, step 3 is to operate the solution. Make sure the teams are ready. They are ready to go. They are trained. They are fully trained. They are embracing the change. They are embracing the transformation. They are able to support the solution. When the calls come in from customers, they are ready to go. Thank you very much for your attention, and I'm ready for questions and comments.
Hey, Randy. Steve Pote, Pote & Associates on the program committee. I obviously spent a lot of time on this presentation. The first thing I think most important of all with regard to your convergence demands are slide 25, which shows optical power levels, Q factor, and OSNR. If you're going to have coherent optics on routers, those routers have to be able to support providing those statistics. So you work for Cisco.
Yes.
It's a router company.
Yes.
Do the Cisco routers support all those specifications?
The simple answer is yes.
For 400?
Yes.
For 400 ZR or ZR plus?
Both ZR and ZR plus.
That's the first step.
Yes.
Second step, you talk about your optical network as being essentially a router. I'm sorry, I shouldn't say router, a ROADM-based network.
Yes.
Do your ROADMs support mixed configurations where you can have part spectrum that is 50 gigahertz, assuming it's already been deployed as 50 gigahertz. And secondly, one that can support a new set of filters, programmable filters, to support the 75 gigahertz spacing required for the DCOs.
Yes.
At 400 gig generation, of course. At 800 gig, it's different. So.
Yes. Again, the answer is also yes.
Okay.
That's very easy. Sorry, that's a joke. Yes. The second question, yes, it's a flex grid. With the flex grid, you can configure your grid.
Right, but we're talking about like currently deployed optics. So the first generation ROADM networks that you deployed were all fixed grid,
Yes.
50 gigahertz.
Yes.
So those have to be either thrown away or you have to basically split your spectrum and
Well,
say, only part of my spectrum now can be fixed optics using transponders. The other portion now is going to be able to support 75 gigahertz spaced optics to support 400 gig.
Okay,
How do you make that happen in your operation system?
tough, very difficult. Yes. Let me first address that 50 gigahertz. I didn't get a chance to speak about the 50 gigahertz. Right, with 50 gigahertz, of course, you're not going to be able to do 400 gig because it requires 75 gigahertz.
Correct.
So with the Cisco's ZR Plus, we can step down what we call the legacy 200 gig mode. So with the legacy 200 gig mode, not the standard 200 gig, standard 200 gig uses QPSK is still running at the 60 gigabytes, not going to work for 50 gigahertz, right? With the newer software that's coming, iOS XR 791,
Yep.
we're going to be able to support the step-down version of at 200 gigabits
Per second, you can basically go and run at QPSK as opposed to running 16 QAM.
Yeah, we're running, yes, exactly. 16 QAM or 8 QAM. Well, 8 QAM is not fully tested, but 16 QAM is supported. It's running much lower than the 50 gigahertz.
Okay. a lot of stuff to be done yet.
Yes.
I could go on with more and more statements. but
Yes,
I'm not gonna
I'd
do
love to catch up with you. Yes, thank you for the questions.
Joel Yeagley, Fastly. I had a sort of similar and related set of questions because a number of things that were in there were things that I was tempted to ask. But I'm seeing systems that are higher than 400 gig, I mean muxes mostly, that need substantially wider spacing than either 50 or 75. And how are you accommodating those operationally, or are you? Like if 200 gigahertz spacing, for example.
You're talking about the optical line system or the routers?
Well, I mean,
Maybe you can
if the
clarify.
router is okay, so if I have a mux that I'm pointing into the OLS and the mux is an 800 gig mux or a 1.6 T mux, how do I fit that in this system? I'm seeing like 20 or 40 wavelengths at 200 gig spacing and like not like you don't seem to have a future that where 50 or 75 gig spacing is like adequate, right?
Check out our new NCS 1010 line system. It's a flex gray. It can support 75 gigahertz. It's very tiny box, and I'd love to talk to you about that box.
Yeah, and is it going to share with some 200 gig?
Sorry, 200 gig?
Is it going to share with some 800 gig muxes like in your DCO or no?
Not for that line system, not for NCS 1010 box. We're coming up with a different box. That's the NCS 1000 series. That's going to support the 800 gig.
Thank you.
Yeah, thank you for the question.
Have we got time for another one?
Quick.
Okay, Blake Willis from Zayo, great talk. Some of these optics operate at 70C plus. Is there a fire risk issue perhaps with plenums and overhead cabling? Do you have any return on experience from field teams running lots of them and any specific handling advice? So specifically around the temperature.
You're talking about recommendations for cabling? Sorry, I couldn't quite hear.
These optics are running at 70 Celsius plus.
Yes.
Are there issues with cable melting that's near them, or has there been any issues that you've heard about?
For the ZR Plus, there's definitely running a much higher temperature because of the heat it's generating. So what we have done, if you look at some of the Cisco solutions, what we're trying to do is that space them out. So we put the ZR Plus into the event ports. But the ZR, there's no limitation. ZR, you can put any ports you want. For ZR Plus, because again, it's driving much more heat, and you have to follow the rules of the LAN card. So for certain LAN card, not all of the LAN cards, for certain LAN cards, the ZR Plus, you have to fit into specific ports. Otherwise, it won't be recognized because of the heat that it's generating. I hope I answered your question. I'm not sure.
My question is somebody.
Online.
Oh, somebody online.
Online
Okay.
question.
Okay.
Excellent. Well, we're a tad bit over on time, but I do want to thank Randy for his presentation today. We have a round for him. Thank you.